Okay, so we were actually looking at the SIP reply actually last time, and we have looked at that. So request and response, these two things actually technically was covered. But when you actually the abstraction, the way it is being defined in the SIP RFC, we do not define everything in one single go, we define it in form of layers. Okay. So the lowest layer which is being specified is how basically the syntax and encoding of all the requests and responses, that is the first and foremost thing. Okay. So this is nothing but syntax and encoding of all kind of possible requests and all kind of possible responses. So there is a generic definition, and this is can be done through a grammar, and this grammar is known as BNF. Is something very similar to ASN, abstract syntax notation. Okay. This is, I think, let me write down the proper spelling. So this is a formal way of specifying the syntax. Okay, I will give an example of this. We will specify in our own way, and most likely that is BNF. And once you have this specification, at least you know how to form a request and how to form a response for every request. There can be multiple requests, there can be multiple responses which are permitted. So once this abstraction is clear, so at least you know how the message will be formed. There is like how to write a letter. There will be dear sir, there will be address, there will be date, then you will write how are you, whatever it is, then you will write whatever you want to say. After all preamble, then you will say thank you, goodbye, your name. It is a format, it is a syntax. You will be using English language or you will be using Urdu or Hindi. That is kind of encoding, how it will be depicted in text. You might write in Roman, for example, write in actually Roman script, but you are writing Hindi language, that is possible. Okay. So we do that actually once in a while. So all that is specification is given by this. So once the letter is being written, closed, sealed, what has to be done with that? Okay. So next layer is talks about how it will be transported. So next layer will be transport. So this is the lowest one. So next on top of it. So layers are like this. So whatever functionality, abstraction or whatever it is provided by it is need not be known by this guy. This guy just passes on the information and this takes care of it. Okay. Actually this is the way it is going to happen is, whatever you are going to generate with this BNF grammar specification, the message, this will be passed using a transport. Okay. So transport layer can be UDP, can be TCP, can be HTTP, or can be anything. It is basically message being encapsulated and then being transported over to the other person. So it defines that particular transport. And similarly how the responses will be sent back. So this can be any one of those. This is basically mechanism how the message will be transported. So this is how the message is formed, and this is how the message is transferred from one entity to another entity. That is a transport layer. Okay. So I think I should not call it a lower layer because it is not running on top of it actually. Because whatever you create, that is being transported, so that becomes an entity for this. These two are separate, but that is the way it has been written, lowest and transport layer in RFC. Then there is a third layer. They do not write bottommost, upper layer kind of thing. The structure is not used the way it is used in networking. Third is what is known as transaction layer. What does it mean? For any kind of signaling, any signaling will consist of multiple transactions. Okay, maybe I will send you an invite, the response will come for the first transaction over. Based on that, I will decide on some other transaction which need to be done. So every time there is one transaction which will happen fully. Okay, and it is possible I do a transaction with you and you give responses, so that's a transaction running. He is now on my behalf is transacting with somebody else. Okay, so a client will be transacting with SIP proxy. SIP proxy will be transacting with another SIP proxy. Okay, and each transaction is separate, each transaction is independent, but they are initiated by earlier transaction.
What's the difference between transaction and message?
Transaction, there is a finite state machine. The message once you transfer, see for example, how you will ensure reliability? I am transporting over UDP. UDP has no reliability. You send a message, you create the lowest layer thing, the message through encoding and whatever it is, message format. You send the message over UDP using that transport. You have done the transaction, now you are waiting for the response, message is lost, what you should do? So there has to be some transaction machine, a finite state machine which has to be implemented, which will keep track of the transaction till the transaction is complete or abandoned.
That could be the stateful proxies to maintain the transaction state.
Stateful proxies, if they are implemented between client, I can have a transaction with this, it is not transparently moved out. Okay, this transaction is only between these. This will result in a separate transaction with another proxy.
The transaction is point to point, messaging is end to end.
Not necessarily, not necessarily.
The transaction is point to point.
Transaction is point to point, yes, it's point to point unless you have a stateless proxy in between, because any request which you will send through the transport will be transparently transmitted to the next guy. It does not maintain any states. If it is a transaction, then this will maintain the state of that. Within transaction, whenever you are sending messages, you are changing your state. When you are getting back the message or responses for the transaction, you are changing the state.
In the stateful proxy, there are two transactions, server transaction and client transaction. For one side,
For stateful, there is no client and server. Whatever comes, it simply just transfers. Whatever is coming back, simply transferring here.
and for other side, when he is forwarding the request, the proxy when
Is a stateless, it cannot maintain a state.
then stateful I'm talking. Stateful I'm talking.
Stateful, there is only one transaction. It can result into another transaction which is coming here.
So what we get for this side, this is a server.
There is a server here and there is a client here. There is a client here, there is a server here.
So what transaction we call it? Client transaction, server transaction?
There is one client transaction, other one is server transaction. Client transaction, server transaction are actually finite state machines. It's not one transaction. This actually the term which is used here. Okay. So transaction layer is what is the third layer. And formally transaction is defined as a request which is sent by client transaction is an instance which gets created in the client. Okay, it's not a transaction. Client transaction is an entity running in the client. Similarly, there is server transaction. So request is going from client transaction, which will cause a state to be changed. So if loss happens, it has to be retransmitted after certain time out. For example, this is going to be taken, so reliability is the responsibility of this, irrespective of what kind of transport is used. Transport can be anything, remember. If it is TCP, most likely it is reliable, UDP it is not reliable. Remember when I took the Bob and that Alice example, it was a UDP based transaction which was there in that request response. Message could have been lost in UDP. What you will do in that case? So client transaction will remember that the response has not come within certain time, I have to again retransmit the transaction request. Okay. So is a request sent by the client transaction along with all the responses which you receive, not one response. You send a client transaction sends a request, then all responses which comes will be included, and this whole thing together will form a transaction actually. And this is sent using transport layer. Is a different kind of abstraction, it's not exactly the same way. So it takes care of reliability. But when you implement a client transaction, there is a finite state machine which is going to be maintained for that. So remember for data link layer we had a finite state machine on two sides which can take care of the reliability of the message transfer. In case a message lost, you will time out and you will again retransmit. Message sequencing can be taken care of. Okay.
When instance any server, suppose a stateful proxy is there, it's acting both as a client server, is sending the request, generate the request and send to other.
It is going to have a transaction user setting inside
No,
it.
when it's returning the response, when they will receive the response, how it might be this same response of this particular transaction. You were saying this instance, when I send a request, proxies forward a request and we will receive the response.
There is a dialog and there is a corresponding remember sequence number for the command. So dialog will give the basically complete dialog which is happening for that corresponding to that call setup, and then command sequence tell this transaction corresponds to which command. For each command there will be one transaction which will be created. Transaction user can issue multiple commands. So the layer on top of it is transaction user. Okay. So this will handle all application retransmissions, matching of responses to request and application layer timeouts. Okay, that's what I was telling. This will take care of, I think this is important thing because otherwise there is no reliability built in. Because application can actually use UDP.
So retransmission responsibility
is by this transaction layer.
Transaction layer in proxy or in
Everywhere. Transaction is between two endpoints. See, it's not between Alice and Bob. It's between Alice and proxy, whatever was that Atlanta proxy. There is a transaction which is going to run between them. Similarly, between this proxy and another proxy, there is another transaction between this and Bob. There is another transaction which is running.
No, so who will realize that they have to retransmit? Alice will realize they have to retransmit.
Alice will realize for retransmission here. This will realize for retransmission of message here. This will realize for this section.
No, so my question is this, whether this
What is happening is in between this there is something called transaction user TU. Okay. So when this guy actually sends a message, this will create a transaction RIP4 corresponding to. See, this is a transaction user is a layer which is on top of transaction layer. Except stateful proxy, stateless proxy, all other entities will have a transaction user. So this transaction user has to talk to this transaction user. So for that it will create a transaction layer, a transaction will be created. So transaction instance will get created for invite, and this will go here, and there is going to be a, what we call, this is a client transaction, a server transaction will get created, which will then send a, for example, I am still trying 100, and then this will be giving a message to transaction user. Now this server transaction will remain as it is, this will not still be dead, its transaction is not over. Transaction user will now know that I am a proxy, I have to now forward it to appropriately. So transaction user now will try to find out which is the other proxy to whom I need to send the message further.
My question is, when the proxy, the retransmission is message of done by LS, so whether this retransmission message will be further forwarded by proxy?
No.
When you have proxy?
Retransmission is only for the reliability between these points. See, message can be lost here, UDP is lost for example. This guy never received anything. What you will do? This will still keep on waiting, I have sent an invite, I will get a response. That can happen, it is a UDP transmission. See, if I do a very simple thing, on UDP I am transmitting, transaction user got created, you want to make a call, it creates a client transaction, it sends an invite, and there is no client transaction technically. You are saying I am directly going to use transport, this layer is not there. You form an invite, you send it, you went through UDP, it was lost. This guy even is not aware that there was an invite being sent to him. Then what you will do? UDP packets are encapsulated on IP packets. IP packets can be lost because of congestion. Then she will keep on waiting for all the time for getting even 100 OK kind of response. So there has to be timeout, you have to again try it. But should it be done by transaction user? His intention is I want to make a call, that's it, invite is sent. So let this be responsibility of the client transaction for retransmission.
So this proxy does not maintain a timer for those. Proxy does not.
Why proxy will maintain? This will maintain a timer. Na? Client transaction will maintain a timer. There is a time. I said there is a finite state machine with each client transaction and each server transaction. So when this guy want to send an invite, it will create a client transaction which will have a finite state machine along with all timers and everything, which in turn will send an invite request through a transport mechanism encoded as per this lowest layer, and it will maintain a state. Now it will wait for some time. When timer expires, it will assume it has not been done, it will again send the thing. Remember, command sequence will tell if this has been received correctly here, timeout has happened. Even if a duplicate goes, it knows that it is a duplicate. I have already received this command sequence. There is a serial number being assigned, okay, and there are reasons why serial number has been assigned, and this is a traditional number, it keeps on incrementing every time you put next command. For every command you are going to create a separate client transaction. It is possible that you can do even a cancel, for example. Cancel is a special command. When you give a cancel, it will create another client transaction, not the same client transaction which is supposed to be cancelled. And this new client transaction will send the cancel command, and it will refer to the earlier transaction, earlier command, which in turn will go here, and then there will be a server transaction which will now clear all the state for corresponding to this, will send the appropriate response if it requires, or the cancel will send a response back. In turn, it will tell the transaction user, which in turn will clear up the client transaction. So cancel is also tricky in this case, it is not a straightforward. It is not control all del. In fact, nowhere it is control all del. Control all del itself is a complicated process if you put it in the shell, or a control C if you do in a telnet transaction. A very similar things actually almost will happen everywhere. Sometimes you can abort TCP connections. Server side times out if you do not get a packet with or a message within certain time. See, most of the protocols by design use something called soft state. They do not have hard state. So they remain alive, they are active if they keep on getting something what we call heartbeat messages from the other end. The moment that heartbeat message does not come for certain time, it will assume the other guy is dead, or he has forgotten, or something has happened. You simply reset everything, all data structure on the server side. Client side usually will keep on, will time out. If the response does not come, again try, It will do it multiple times. It does not happen, server must have been dead. It aborts and tell the higher layer something has happened. Same procedure will be followed here, but it's done in a different way. The naming is different. That's the only thing, and it's on in application layer because your transport is directly UDP. This is only the encoding of the message in the application. So this message is technically being routed over this transport, but this message is generated by transactions, and client transactions and server transactions are created by transaction users. Only in stateless proxies this is not, the transaction user is not there, so correspondingly there is no server transaction and there is no correspondingly client transaction. So whatever comes, you simply change the header as per the policy and transfer it. You don't even worry about it, what has happened, what has not happened. It's the endpoints which will worry if it is lost or if I have done a wrong translation. Reverse whatever come, you again do the translation and pass it back. Okay. So they actually handle what we call application, take care of application layer retransmission. I think I will write it. Then matching of responses. Each request will have a separate client transaction being created. So when the responses come back, they are transferred to appropriate client responses.
Controller of all transaction there is transaction users.
Transaction user is the
So in case if I am a client, I want to set up 5 connections, there will be one transaction user and there will be 5 transaction layer which will be initially set up.
Yeah. And of course, what we call application layer timeouts. So any what we call UAC, UAC was user agent client, and whatever it will do, it will be through a series of transactions. So UACs as well as, so this is always will be working through series of transactions. So now it's important that UAC and stateful proxies have transaction layer. In fact, I should write transaction because TLV used for transport layer mostly. Stateless proxy, no transaction layer. And of course, all the time this client transaction and server transaction they are always represented by finite state machine. Finite state machine is where finite states are there, and depending on whatever is the input, the state will change, and there will be a corresponding output which will be coming out. FSM is that. FSM stands for finite state machine. And of course, the fourth layer, as I mentioned, is always going to be transaction user. This is known as TU, transaction user. This is a user which is technically a software running there which creates transaction machines, client transactions and server transactions. And except the stateless proxy, all SIP entities are transaction users. There is no separate, all entities itself are transaction users. Okay. So proxy is a transaction user, it is not nothing inside the proxy itself is transaction user. User agent client is itself is a transaction user because it creates transactions. Okay, proxy also does the same thing, registrar also does the same thing. So except stateless proxies, everything else is, every other entity is a transaction user. Okay. So the way it is going to be done is, what you will do is, it will create a client transaction, and for this it will create client transaction instance. Actually there can be multiple client transaction instance, as he has mentioned as a case. You want to make multiple calls or multiple invites to be sent, you will create for every kind of thing a separate instance. I already gave an example. You create an invite, you create a client transaction instance, you want to cancel it, you will create another client transaction instance in that case, which will then be referring back to this, because it is a cancel, it is a separate transaction, but it is going to refer to an earlier transaction. So there will be a server transaction correspondingly, which will go and do all cancellation thing on the server side, and once the confirmation comes from that side, it will do the cancellation on the client side. Okay. So here cancellation is slightly different. So you create a transaction which is an invite, for example, on the server side. Suddenly you want to cancel it, you will don't cancel it directly, you will start a separate transaction which goes, creates a cancel server transaction. It will reference will be given to this. This knows from that reference this has to be cancelled. This will be cleared off, the response will come back. Once the response comes back, you will clear this thing, you will tell TU and this will clear off this one. But there are two separate transaction instances which gets created. And for creating a transaction instance, you require a request, you require a destination IP, you require a port, you require a transport, UDP, TCP or HTTP, whatever it is. And once you give this thing based on, this is where the request has to be sent. This will always lead to creation of client instance, client transaction instance. And transaction instance will be of the type request, and the message will be transported to an entity on this side, where server will keep on waiting. The moment a request come, it will check, it will find out there is no server instance for this, it will create a server instance. It's like forking. For example, whenever you are doing telnet to a server or SSH to a server, there is only one server running there. First time the request goes, it will figure out there is no instance running, so it will actually do a fork. Fork is creating a copy of yourself, and then that will be made responsible to response to this. So you will create a server transaction instance. This will be done exactly same way, the way it is done in network. You will create an instance on the server side also. Okay. Cancel thing I have already told, and of course this is basically what are the layers which will be used for communication purpose. Okay. Now most of these SIP elements we define something called core. Core is the functionality. Of course this is only an abstraction, this does not tell that software has to be designed only in this way. It depends, whatever way you feel comfortable, you can design your software, but this is an abstraction given in RFC. So you assume that if somebody else designs software in whatever way, but he is following this abstraction, you should be able to communicate with him. Only that thing has to be ensured by you. You don't know how the other person, other server or other SIP entity have been implemented. So you have to ensure, if you are making a client, it should be able to work with anybody's proxy which is SIP compliant. If you are designing proxy, it should be able to talk with any other proxy built by anybody else or any client. Registrar, it should be able to talk with any kind of proxy. But internally how you implement, it's I think implementer's issue. So that IETF should not govern, because that innovation I think we should leave it to the inventors. You can do a lot of innovation by implementing the software itself. Okay. So in fact every entity, every SIP element, we define cores actually in this case. Core is the implementation. Core is technically the implementation, and they technically represents TU, client transaction instance creation mechanism, client transaction instance, everything put together in software, that is core. And this will be existing for every entity except the stateless proxy. Okay, so that is core. And core will depend on whether it's a proxy core or whether it's a user client core, or whether it's a user server, user agent server actually core, or it can be registrar core. So you can define, or you can redirection server which is there, it can be core for that. Okay. And remember, for every transaction will get completed when you will get a final response. It cannot be completed before you get a final response. So client transaction and server transaction, this transaction will get completed, then this server entity can go away if it requires. Okay, and this will happen only when the final transaction has happened, a final response has been received for a request. So now if you carefully note, when the LS actually has sent a request, there was an invite which was sent. Final transaction happens, final response comes only when the final responses from all others have reached here. Then only you get an OK. An OK is kind of a final response. So in fact all response codes which starts with 2xx, 3xx, 4xx, 5xx and 6xx, they are all final responses. One XX is not a final response. It is a kind of a temporary response. You call it provisional, and it will not terminate the transaction. So your client transaction have to be maintained if you are getting these provisional responses. You cannot terminate that. You cannot close her. 1XX series will not close the client transaction. Only anything related to this will close. Now these requests and responses now can keep on moving from one person to another person and so on. So there are terms which actually things which can happen, which we define. So one thing which can happen is known as loop. So this is a SIP phone, talk to a proxy. Proxy figures out still transaction is not over. This request is sent to another proxy. This proxy analyzes the invite or whatever request which was sent, and this request comes back to this guy, and this request again goes back in this direction. That's very important. Then it is known as a loop which is going to happen. So this is loop. Something also, another interesting thing which can happen is you send a request to a proxy, this can send to another proxy, this in turn sends it back, but this new request which has come back through some whatever way, there can be other proxies also, is not going to go in the same way, it goes to somebody else. Okay. So this is different than loop actually. This can happen because of redirection. Okay, this can happen because of redirection. Because you are probably registered with this domain, but then you have moved to some other place, so you told this guy ki you tell this person where I am. So it tells this person that I am here. Okay, so it actually passes on the request to this guy. This guy then looks, because now that, remember that SIP proc, when I do redirection, so redirection means the source, the original destination is moved to, converted, mapped to another new destination. So Bob was at bloxy.com and then he has moved to say some xyz at atlanta.com. So that's a redirection. So atlanta.com is back here, so request comes here for xyz. Or maybe some other guy whom this guy cannot go directly, it comes back here, which in turn sends the response request here. This kind of thing is known as spiral. Okay, in this case.
But this is a legitimate
This is a legitimate entity.
because
This is a legitimate. Is a
But
legitimate.
Loop will be endless, or I mean, it will come out.
It depends. Loop usually is not desirable, but yes, it is possible. If loop is there and loop is legitimate, yes, it is possible.
That's why we put
But loops need to be resolved in that case. Probably one example is Bob at bloxy.com. His job actually got moved, so he still retained that account. He did a redirection. He joined somewhere as say Johnny at atlanta.com. So the call was redirected here, and then by the time he also actually has moved, this entry is still retained, and now he is some क्या बोलते हैं Jojo at bloxy.com. So it's being again redirected here. So loop is a still valid thing, but the signaling is happening in the loop. So ideally speaking, he should have actually, the error here is that he should have now told this guy that whatever is Bob at the bloxy.com is same as Jojo at bloxy.com. Okay. So redirection can happen here itself directly. Na? So earlier this loop is nothing but what we call a data which is not required, a configuration which is bad actually. Of course, it's not going to impact, the call can still be routed, but it's not desirable. Mostly it will happen because of redirection, because for whatever reasons. This redirection is probably you are moving and then you are even returning your earlier account and redirecting to somebody else, like dot forward in email. But dot forward in email, for example, from IITK you say it goes to whatever is xyz at gmail.com. There you do a dot forward, it will go to somebody else here. It come to iitk.ac.in but different name. But server is still the same, but name is already changed. And that dot forward again sends it to gmail.com with a different name ID, different mail ID. And of course, if you create a loop, same mail here, it will keep on looping indefinitely. Now that is invalid thing. It will not terminate. Invalid loops are not allowed. And how the invalid loops will be terminated?
maximum forward limit.
Yes, there is a maximum forward limit, and that will be terminated. It should not happen, keep on happening indefinitely. So loops usually, which are invalid loops, are taken care of by maximum forward hops, which are there. And then of course, this is
The only way is there to handle this loop is maximum forward and other mechanism is there. Other mechanism is there to handle it.
you don't handle it, simple. So if you see, I am telling here it's a loop. Only way this can be said is if as of now, because there is nothing has been received from the endpoint, the call ID and the tag of the sender, these two pairs actually if you combine, and if those are registered here, you just keep check if there is any other request which is coming while it is this particular transaction is pending, which corresponds to the same particular call ID and same particular this thing and same particular what we call sequence, command sequence. If that thing comes, yeah, it's probably is a loop. That time you have to decide what has happened. Then you check this, then you actually can do these two can do the pairs can do the check, and then user need not even offer. He can directly say bob.bloxy.com should be now directly forward to this, loop is removed. That intelligence can be built in this system. Now that is left to the programmer. RFC does not talk about it. So if you are smart enough, actually you can implement this and then make your proxy better. or you can at least inform the user, we found a loop for you, would you like to correct it, and this is a way to correct it at least. Okay. Spirals also can exist, but I think spirals are also not desirable. If this could have been directly from here, it would have been better. Now this guy can do this job and short circuit directly from here. So you will actually reduce a lot of load on these machines by removing loops and spirals.
This will be, sir, since in GSM we are having that roaming concept, so same concept will be here. So they'll have to do it.
They have to do it, but if these machines are entity, they can figure out a call lag, or not call lag, that's dialogue. But dialogue is not there unless you get the response back.
Because this will be of different network provider, that will be of
So only the invite will go in this way, but the response will come pretty fast. Basically, they will always say they will not put what we call that thing, via field. So whenever you are doing redirection, don't put a via header entry into that. Okay. But the problem is, if this is going to send to another proxy, then this will not know it is going to go back to this guy. And it puts a via header, then it becomes a problem. Now those complications are there and we have to live with those. And these kind of things I think has to be identified by processing. See, because this will not be cleared, remember. So whenever a new call, a new invite comes, whatever is the current transactions which are pending, which are not clear, compare with all of them, and based on that you decide if something is being duplicated. You identify loops or something, and then at least talk with those proxy servers directly and resolve the matter. So that intelligence has to be part of the proxy design. So it's not a trivial thing. Okay. So this is also not an obvious stuff. Now I talked about that back-to-back user agent. I talked about stateless proxy, stateful proxy. I can now diagrammatically actually represent them once I have come with this transaction stuff. So I talked about this thing, B2B user agent. So this is a special kind of proxying thing, but actually it is not a proxy. Proxy is only for signaling. Back-to-back user agent also takes care of media. Okay. So there is a proxy, this is a B2B user agent. So media is going to be transacted on this, signaling through this particular path. So there is one user agent, there is another user agent client, user agent server. Media and signaling both will be transacted here. And this can make another SIP trapezoid. That's a back-to-back user agent. If it would have been the proxy, the media is always transacted directly between these. Certain media gateways can be built, it can be of this kind.
signaling and data media.
Signaling and data both, or media we call it.
This will not be called a proxy.
This is not a proxy, this is a back-to-back user agent.
How can you differentiate if it is communicated?
Proxy is only for signaling part, this has no role for media. Media is transacted directly between peers, but this is like another peer. So this guy cannot see this and this guy cannot see this. They both have to go through this for signaling as well as media. This is kind of a media gateway.
So what advantage will get?
If you want to tap the call along with all signaling information, yeah, this is the best approach. Back-to-back user client is the best approach in that case. So don't allow the call to be set up between these two entities, use B2B UA. So tapping usually will require this, because I am now not using Megaco here for controlling this particular entity, media gateway. I am using SIP only. So it is, you will actually see your user like is this, but actually it is not this. So similarly this guy will feel as if this guy is here, but actually he is not. And they are just back to back connected, spliced together in software.
But whenever he is giving us the address of an IP as a back response, will he not know?
No, this guy will do the signaling here, this will still keep in pending. This B2B user agent will ask this client to actually now talk to this guy with all the information given by him, and it will behave as if he is this guy.
So forcing the request to go through this path.
Yeah,
But it's not a normal feature.
it's not normally, it will not be done. Normally it will not be done. But these kind of specialized entities will also exist. So I think call stateful proxies and transaction stateful proxies also need to be explained.
Sir, how is the difference from poking? Poking we also when we normal response go and we get this response have to go to another path we are doing the typing. We can use the poking also, no? Poking is what? We are
Forking is when the proxy on the receiver side gets the message, it now signals to many entities, not one entity, which are registered for the same user.
this is a parallel poking.
Is a parallel thing, and the responses will come from all of them, and it will intelligently will figure out as per the policy that only one of the message have to be passed back.
So when we do the parallel poking and when we do the sequential poking.
Parallel forking, for example, if you have set up as a feature with your registrar, you want that all three of my phones should ring when a call should come, and I can pick up from any one of those. You can say, okay, first of all try at my home phone, give 4 rings. If I don't pick up, then my office phone should ring. 4 rings should be there. If again it is not picked up, then my mobile should ring. That's a serial.
So we can use also mix approach.
Yes, you can. That's your thing. You have to do the, everything has to be registered with the registrar, and this will get everything from registrar and do as per that. So policy of calling is again left to the implementer and users. RFC does not define that. In fact, there are many set of RFCs. Other RFCs talk about this thing.
It's a user choice.
It's a user's choice. It's a policy. So next is the message format. Okay. So this I have already mentioned, but I am just formally writing that. This should not take much time. So generic message will be always look like this. I am now writing the grammar of that actually. It will always consist of start line, optional headers which will be there, CRLF, carriage return line feed, a gap, and then you will have the message body which is optional. I think optional is with this, and this is a compulsory thing. Flexible. And a start line can be either request line or a status line. And even when message body is not there, this is an optional thing, but CRLF is compulsory, start line is compulsory. This is a variable field actually, message header, they have to be there. Message body is optional. So because I know there will be one line, no, this is a variable number of lines, the end of the header will be identified by CRLF, which is again compulsory thing. You cannot identify the end of this number of header fields unless this is there, so that's why this always has to be present. This is an optional thing. That is the BNF grammar actually which I am writing now. And request line will look, now these are two options, request line or response line. So request line will be a method that is space. I have already mentioned this thing earlier, but I am now writing formally. Okay. Then there will be request URI. There will be a space, single space character, and then of course SIF version line feed. say version and CRLF we call it, carriage return and line field. You will come back to the first thing. So that's the request line which will be there.
Then this length of the message and all that will not be there.
Hmm?
The generate message. After message body, the length of the message and
Length of the message will be part of the message header. It is part of the message header, content length. That will define how many bytes will be there in the message body. So if it is 0, there is no message body. So the methods which are permitted, so far I have not talked about all methods. So all the methods which are there are these, which can go in any SIP request. So one is a register. Invite, we all know what is invite. We also know what is ACK. It is not a response, remember, it is a method in the request. Okay, in the request line. Status line is where the OK will come. So ACK is not an response, ACK is a request. Okay. Then there is a cancel. By options. This is for registering the contact information. This is used for setting up of your sessions. This is for terminating the sessions. This for querying the servers for their capabilities. So this is as per RFC 3261. For other RFCs, also actually specify other methods, but these are the ones which are required by every implementation. Other things are nothing but SIP extensions actually. There are other methods also.
What's this asterisk? All
Variable length, variable number of headers. It's not one line, there can be multiple lines.
Which include what? Via header field.
See, that's why CRLF is there. Na? So you identify, you know our first line is this line, you know this CRLF, all lines in between them is message header. So it can be one line, it can be 2, it can be 10, it can be 20, nobody stops. One of the field always will be content length, which will define what is the message body size. Okay.
There is no CRC in this case.
There is no CRC. That's taken care of by UDP or IP packet or data link control. Okay. So usually if there is going to be noise, DLC will take care of that and will do the retransmission.
What's the difference setting up session and managing the session? Here is the setting. This request will take care of the session, setting of the session.
This for setting of sessions.
So what's the session management then?
Session management, if you do re-invite, that is also again invite command only, but you with the different parameters.
Session management will be transfer and termination only.
Modification of parameters also, and termination, everything. Yeah, this by is for management, or you change the parameters of the media. Okay, so I close here, and then more of it actually we will discuss tomorrow morning.